Hi, and welcome to another old steam-powered machine shop, back in the cold and damp New York shop. The first couple of days I had the shop open, it warmed up a little outside, and the condensation on all the cold iron was really unbelievable. Everything was soaking wet, and so I'm kind of panicking, running around with a towel, wiping everything off and oiling everything down. But in the last couple of days, it's gotten passable. A lot of viewers were kind of interested in what it was like to set the shop back up after being winterized. So as I was doing that, I just shot some video here and there, and I hope you can make some sense out of it. Taking a trip next week down to Wilmington, Delaware with a friend of mine to scope out the planer situation, and I hope to be able to pull the drive system and the motor down and maybe lighten up the machine a little bit, take a few pulleys off that might get damaged or something, and get things moved around and get it moved out of the building. So that's coming along. I was in the process of getting the shop up and running, and I got a kind of a rush job in. You'll see. This guy needed this done right away, so in the latter part of it, my camera batteries were starting to die, and I didn't have time to charge them up, so I didn't really get a finished view of it, but you'll get the idea. Looking forward to this season. Hope to have some good projects for you, and appreciate all your comments and suggestions, and we'll be talking to you later. Well, the first thing is to put the hand holes back in. These are inspection holes. There's 10 of them, and they're basically so that you can look inside the boiler, inspect it, see how things are doing. This one has the fusible link in it. It was new last year. ASTME approved, legal fusible link. And what that does is it screws into one of the flues, right into the side of the flues. In fact, that particular flue is a thicker wall than the other ones, so there's more area for thread, and it has, the center of it is a Woods metal, it's sort of like a lead based, it's a complicated alloy, but it basically is a very low melting point material. So if the water level in here should get below this plug, the heat from the flue on the other side will overheat the plug, and that material will melt out, and it will blow steam through the plug, down the flue and up the flue, and it's supposed to help extinguish the fire. I think it's more like an alarm than a fire extinguisher, but they're required to be in all S-stamp boilers, all code boilers, and I replaced this one last year. That's the New York inspection number. This is what the handles look like. They're cast iron, the stud screwed in, and they have a rubber gasket. This is a new one. I put new gaskets in it last year. I try to get 2 years out of them. And that's the size, 3 by 4.5 by 1/2 inch. And this is a cross piece. Now I've got them all marked, numbered and marked, so they go back in the same hole and in the same position. And I use a very light film of Teflon based pipe dope on these. Now there's going to be a lot of people that think this is not the proper thing to do, but I'm not saying I'm the expert on this, but this works for me. Because the inside of the boiler is a little rough, pitted, and I've had problems with them not stopping leaking, no matter how hard you tighten them. And you're not supposed to tighten them really tight, because the pressure against this side compresses the gasket also. This shows you a little bit about the construction of this boiler. This is a 1924 Monday steam hoist boiler, and I think it's built a little bit ruggeder than most vertical fire tube boilers. This is one of the lower handholds, and you can see the way it's constructed. This surface back in here is actually the firebox. It's an inner wall. There's about 3 inches of water here separating the outside shell from the firebox, and the bottom of this is actually a big ring that goes all the way around the bottom to separate the two walls, and it must be 3 inches thick, 3 inches wide, and the diameter of the bottom of the boiler, and these rivets go all the way through. I don't know if you can see. Oh, you can't with that ring. And that's what forms the bottom of the boiler. These are stay bolts here, and what they are is threaded bolts that thread through the outside shell, through the water area, and thread into the inside shell, which is the firebox, and then they're headed over. So, and these give the double wall extra strength. All boilers have them. This has got a row on the bottom and a row up here. Once you get up to about here, this is actually, if you look through this one, you can see this is the top of the firebox right here, and this is where the flues start that carry the heat and the smoke up through the water area. So we'll put this handhole in next.
took the gauge off and blew it out with air last fall. Get the water out of it. This curlicue right here, it's called a siphon. And what it is it allows water to condense in it and keeps the hot steam from getting up into the gauge. It's kind of rough on the gauge. So it's not really to keep the water out of the gauge, it's to keep water in the gauge. So this fills up with water, and when you leave it for the winter time, you got to make sure you blow that out with air so that it won't freeze and break. The two injectors here were taken off last fall and blown out with air, so they got to be put back on. That's the Metropolitan. Let's see here. This goes this way. This way. Feed water line hooks up to the bottom of both injectors. It's got the hose that goes in the barrels. Okay, now I'm gonna commence filling the boiler out of this tank here, which is full of rainwater. We got a submersible electric pump in here. Putting it in at the accessory outlet here. And need to be watching these handholds, make sure none of them are leaking. You gotta fix it right then. Tighten them up a little bit. You might have to take them out. You can't do that after the water level is really high. Also, a little bit of pH down, and I've done this so much that I know about what it's going to take. I'll check it when I get the boiler full, but the idea is to get the pH of the water up to about 9 or 9.5, and that makes it very less corrosive to the boiler. I'm on the third barrel going in, and you can see the water is up on the glass about halfway. This one is showing water, and this one is showing water, and this one isn't. Gotta tighten these up a little more, and I got one handhole that's leaking in the back just a little. I gotta tighten. Tom's over here making noise, making a part for his milling machine.
I think I'm going to the hacksaw.
Open the draft wide open. And start with a light fire. Boiler is completely cold. Let it heat up slow. Well, we got plenty of steam now. I got a job in the shop I got to get done right away, so I got to get this thing going.
Okay, the job is this. This is a wheel balancer for automotive wheels. These are the cones that go in to mount the wheel on. These are the new cones. This is the shaft size of his machine. Got to make a sleeve that will work with this to reduce this diameter down to this diameter. Pretty simple stuff. It's just a bushing with a flange on it. I don't know, maybe about 1/4 of an inch thick. So within 1,000th. Okay. Just high-speed steel. Okay. Before we get started here, it's a good idea to try the injectors.
See if the hand copy will work. Just like it's supposed to. When you get a full glass, it's clear up into the top of the glass, so we got plenty of water. Both injectors work. We got 70 pounds of steam with the egg. Well, everything's tightened up. Lube. That's running 5 months.
Okay, this has got to be 1 1/8 with a sliding fit. And this is an 1 1/8 reamer. It just goes in. So I'm about, 10 thousandths under here. I'll run that one through.